Hey, 6th grade. Today we're going to continue our discussion on RP3a and use those proportions to solve ratio tables. So if you'll remember from our previous video, a proportion is when two ratios are equivalent to each other. So we can use that setup to solve for any missing numbers or values in a ratio that has the same rate, okay? So we're going to be using those proportions to solve our ratio tables today, and I'm going to talk to you about how we can utilize these tables to actually put our data on a graph through the coordinate plane to be able to see the change in the rate along the way, okay? So as we get started, what we are given is we are comparing the minutes of music listened to compared to the minutes that we listen to the news, okay? So, if you'll remember from our previous video about proportions, the way that we're always going to set up a proportion is we're going to start with our words, because the order is so critical in anything that we do with ratios and proportions. So we're going to start with our words, and we're going to compare the music to the news. Now we're going to look at what we are given. What do we know? And this one is going to be our known, because both quantities, both units of measurement are filled in, okay? So what we know is that 20 minutes of music is related to 2 minutes of news. What this means is for every 20 minutes that someone, the person who gave us this data, listens to music, they're only listening to the news for 2 minutes, okay? That's the comparison of those two quantities, which is a ratio, okay? Now, then I'm looking at the unknown. What am I missing? So I am looking for how many minutes of news is this same person going to listen to if they are continuing with this rate and they listen to 40 minutes of music. What will the minutes of news be that they are also listening to? So what I'm given is 40 minutes of music. What I'm looking for is the minutes of news. Now, if you'll remember about a proportion, whatever we put on the numerator has to be the same all the way through the numerator, and the same unit of measurement on the denominator has to be used throughout the entire problem on the denominator. Once we have our set up, then we are going to cross multiply to solve for x. So we have 20 times x is 20x. 40 times 2 is 80. And we are going to divide 20 on both sides, divide by 20 on both sides to get x by itself. We're going to use that inverse imp operation, and x is going to equal 80 divided by 20, which is 4. So in this proportion, if someone listens to 20 minutes of music and 2 minutes of news, and that rate continues, then for 40 minutes of music, we're going to have 4 minutes of news. Now, we can also solve this question, which is our minutes of news is given to us, but we are solving for the minutes of music. So we're going to set it up in the same way. We're going to look for our words, which is going to be music compared to news. We're going to use what we know, which is 20 minutes of music for every 2 minutes of news. But this time our unknown is going to be different. In this case, we don't know how many minutes of music, so we're going to put our x there. But we do know that we're using 6 minutes of news. Okay, that's what we're listening to. So we're going to do the same thing. We're going to cross multiply. 20 times 6 is going to be 120. 2 times x is going to equal 2x. We're going to divide both sides by 2 to get x by itself on one side. And 120 divided by 2 is going to be 60. So to complete this chart, we're going to listen to 60 minutes of music compared to 6 minutes of news following the same rate. Okay? Now, here's the next step that you can use to apply this information to. We can use data tables that have two variables, and we can plot them on a coordinate grid, just like their coordinates, to be able to see a visual correlation of what the rate is doing, okay? How it increases, how it decreases. So, in this example, our minutes of music would be plotted as our x-coordinate on our x-axis, and our minutes of news would be plotted on our y-coordinate as our y-coordinate for the y-axis. So our coordinates would be 20 and 2. And then now that we've solved the next rate, we're going to do 40 and 4 and 6 and 60. All right? So now you can see the relationship. Each one of these, remember, a proportion means that their ratios are equivalent. So in our ratio table, all three are equivalent. If we simplified each one of these, we would get to the simplest form of 10 to 1. And that's how we know that they are all equivalent. So this is how you would use proportions to solve ratio tables, and then can use those coordinates to plot this data on the coordinate plane.